Hello and welcome to one of our problems that we investigated in our computer algorithms class. In this class we used the Intro to Theory of Computation book by Wayne Goddard. Today we're going to investigate machine 119. This was one of our homework problems out of the first chapter, and I can remember that this was one of the homework problems that gave me trouble. It was one of the ones I couldn't see right away as far as recognizing the language that it accepted. So I just want to run through some of the ideas that I had coming to the solution of this problem. So here's our machine. We have 4 states. We have 1 except state. So my initial thought right off the bat is that, well, I see the zeros and ones are kind of symmetric in this way. So my initial thought was maybe it's the same amount of zeros and ones. So checking that, we got, say we had 0, 0, 1, 1. 0, 0, 1, 1, we accept. But if we do 0, 1, 0, 1, let's see, 0, 1, 0, 1, that accepts as well, but we could do, I think, let's see, there's one that rejects here. I think we do 3, 1, 0, 1, 0, 1, 0, let's see, 1, 0, 1, 0, 1, 0. That'll fail. So that's not it. So my next guess is, well, we have loops at every state. So the next thing that we can try to do is maybe it's just even length strings. So we test that. Well, we're always going to get. It looks like we're always going to get even length. So let's go. We go 0, 0, 1, 1, we know that's even length, but I think we break it here if we do 0, 0, 0, and 1. So 0, 0, 0, and 1. That breaks. So after that, I had to do a little bit more thinking and investigate the problem a little bit further. So what I end up doing is, if we look at our Python code here, I create the states. So this is state A, B, C, D. And for ease purposes, ease of checking purposes, they're just going to be integers. So just that you know which state you're in at any given time. We're given a string of results, our initial state, and the result is a list of strings that this machine accepts. So in this one, for a range of 100, means it's going to run this test 100 times. So in this test, we either get a 0 or 1. Here's our string, or this stores the either the 0 or the 1 that's randomly picked here, and we concatenate it with we build that with our W. So this string is always being built. So it's always getting a string that's getting appended to. Here we go, our states that mimic our machine M119. So for in state 1, if we get a 0, we go to B. Else, we go to C, or D. I think that's C. I might misdrew that. If it's state 2, same thing. And then all these have the 2 states of when you get a 0 or you get a 1. Now, given that, there's a couple tests that I wanted to run. Are we an even length string? Well, here I ran the program already, and we can see what the string can output as far as strings. And you really can't notice it just looking at that. But is it an even length string? We run through every occurrence of any string that can be in this any string that's accepted by this language. And yes, they're all even. Now the second check here ends up being what I found to be the result. And this checks the amount of 1s and the amount of 0s being both even. So that's true. And if we check that on here, we can surely see that any amount of even 0s and even 1s will be accepted by this language. And that's it.